So, the next guideline that we saw or we discussed in general, I mean we did not explicitly discuss about the thickness part, but we talked about size in general, right. So, thickness. So, people look at usually a cylindrical part and a non-cylindrical part, that is how they decompose a particular part. Okay. So, for a cylindrical part, the thickness is given by its radius, it is obvious. Okay. What is the radius of that? That will be the thickness of your cylindrical part. But not always you are going to have a cylindrical that is completely cylindrical. Sometimes you might have a break in between and they call it non-cylindrical. Okay. A cylindrical part other than perfect cylinders is the one with a regular or a circular cross section with 5 or more sides. Okay. So, imagine that it is not a circular cross section, but it has a rectangular cross section. Okay. So, that is a non-cylindrical part in that sense, because you need to have a circular cross section, right. So, how do I see whether it qualifies for this is I look at the number of sides. So, if it is a square cross section, it has 1, 2, 3, 4, 5, 6. So, minimum 5 sides with 5 or more sides, that is what it says. Whose length is more than its diameter. Okay. That is how you define a cylindrical part. So, if it has 5 or more sides and its length is more than its diameter, then I would still call it cylindrical. It is not a cylindrical, but I would still call it cylindrical provided it satisfies these two conditions. Okay. How they talk about the cylinder is, we will discuss what I have here, but just look at this. Let us say that you are going to gift this to someone. What will you do? You will put a box around it. That is all this one says. Okay. You take a part and imagine that you are gift wrapping it, but a very snug gift wrap. You are taking a box that just encloses this right around that. Then you go and measure what is the thickness of that box, that is all. That is what is the thickness of your part. So, if you take this particular part, you do not know whether to take this as a thickness, whether you will take this as a thickness. These are thickness of the sheet metal, but you are talking about thickness of the part itself. Then what I need to do is I need to put this box, you see this dotted line, imagine that that is a box, that is a gift wrap that goes around it. Then the thickness, of course you know what the thickness is, right, smallest dimension compared to the length, that is called the thickness. Okay. Similarly, you can take this washer for instance. Imagine that you are gift wrapping this guy, it is a small box, or Flipkarting or Amazon, whatever the box is, and you measure the thickness of that guy. Whereas, if you have a cylinder, you just take the radius, that is all. This is what is going to be my thickness, that is what is shown here. Just the radius will be your thickness for cylindrical parts. For non-cylindrical parts, you assume that you are gift wrapping and then you find the thickness or the height of the box, that is what is going to be your thickness. Okay.
So, the non-uniform cylinders qualify as cylindrical parts or?
Sorry?
Non-uniform cylinders?
Non-uniform cylinders.
The radius of the wedge is constant along the length.
Oh, like that, yeah. So, do they
qualify as cylindrical parts or?
do they have more than, so they are not a perfect cylinder?
They are not a regular cylinder.
Correct, that is what, they are not a perfect cylinder. Then you have to go with this. Do they have greater than 5 sides?
They have 2 sides, right?
They have 3 sides.
Cone is an example.
Sorry?
It's a cone, like a cone.
Oh, no, okay. I thought you were talking about something like this. It can also be a cone. It has a sharp edge, that is what you are talking about. So, it has one side and then one side here. So, it is only 2 sides. So, it will not qualify in that sense. So, then what you need to do is you need to do a gift wrap and the largest one will be your this thing. Okay. It has to be a rectangular box when you gift wrap it. You cannot have a tapered one. You understand what I am saying, right? So, you can see here it is a perfect, okay. So, you have to be careful, but the way I guess it is usually the other way of looking at this is you are going to project light on top of this guy, okay. Then you look for the projection and the thickness is the height of that product is what it is, okay. So, that is what it says. The thickness of a non-cylindrical part is defined as the maximum height of the part with its smallest dimension extending from a flat surface. So, you put this guy, it has to come from here, from a flat surface, you place it here, the height of the base will be your thickness, okay.
What about hollow parts?
Sorry?
Hollow parts.
Hollow parts, in one sense this is a hollow part, it is still the thickness is thickness, that is all.
So then we can
No, it is not weight, please understand, this is thickness.
Yes sir, but
Huh.
when we like in this case, if I have a pen without a refill, it's like a hollow thing, but if I gift wrap it, the maximum thickness would be this only, right?
Correct.
So,
The thickness is thickness. How does it matter whether it is hollow or non-hollow?
so the sides inside also we consider, right?
It is just the outside, yeah, you do not worry about the inside part, yeah. It is not it's geometrical only on the outside where you are going to handle it, you are not going to handle it from inside, you are only going to handle it from outside. From that perspective, your question is valid, but we are looking at it from an assembly and a handling perspective. So, you are only going to handle it here. See, the only point in this is whether it is this cylinder or it is a cylinder that goes into your drainage tubes. They are also hollow stuff only, but they are also cylinders, but you measure the thickness, then you necessarily know that that is a much larger thickness than this one. This can be handled by 2 fingers, whereas you need at least 2 people to handle that. It is as simple as it is, that is all, okay. So, for instance, this guy is hollow in one sense. The washer is a hollow if you look at it, if I extend this guy, then he becomes a hollow cylinder, but you look at only the outside. Any questions? Yeah, the other one is, this is something that we have talked about yesterday in one sense, diameter being greater than length. L by D ratio always comes into picture. In case if your diameter is greater than length, then it is a non-cylindrical part. In this case, that is the case, okay. This is your diameter, okay, and this is your length. So, your diameter is larger than your length, hence it is a non-cylindrical part. Therefore, I will put a box around it and I will find the thickness. If you qualify this as a cylindrical part, then the thickness will just be the red line that I drew, which is your radius, but please understand, okay, that is not the case. There is also a diameter being greater than length issue. Any questions before we move ahead? Okay.
What if diameter is similar to length?
Let me think a little bit before answering that. If your diameter is equal to length, I guess they might work out to be the same. If you imagine this guy to be of the same stuff, it will be the same. You can either take the length or the diameter, they will be the same value. So, it does not matter. So, you will actually have confusions only the other way around, meaning if it is close, should you really take this or should you take that? Okay. So, as usual in symmetry we saw time, right. So, with any guideline that is being quantified, you also need to have a time element that is mapped to it. So, we will see in terms of part thickness, it is the same idea, right. So, the thickness in the x axis and the handling time, they call it penalty, because they say that the ideal will be a cylinder, okay, and from there we will see non-cylindrical parts and all that. So, if you look at it, this is the handling time and this is for the cylindrical parts, right. So, somewhere around here, if it is 2 mm, they classify it as thin, and after that they classify it as non-thin. Please understand, these are all again only manual assembly. Okay. So, what they are saying is, if the thickness is greater than 2 mm, okay, here actually the handling time penalty is almost 0. If it is thin, okay, it is less than 2 mm. You can imagine what 2 mm is. 2 mm is probably this much. If it is less than that, it is actually a headache. I have to carefully handle it. I might require 2 fingers, or I might need a forceps to handle it. Okay. That too, if it is long, it might buckle. You need to handle it carefully. So, there is a problem with that. Okay. And as the thickness decreases, you can see here, as the thickness decreases, the penalty time keeps increasing. But we are only talking about seconds here, 1.2 second, that is 1 second. We are talking about 1.2 second. The curve looks big, like it goes from here to here, but it has gone from 0, which is nothing, to 1. This is 1 second, 1.2 seconds, that is all, okay, the handling time. But this is not handling time per se, but it is the penalty that is associated with it, more additional time that you will need. Okay. That is 1.2. But the catch is, please remember, you do not do one assembly, you do, what did we discuss yesterday, few thousands a day. So, this will translate into, for easy calculation, let us say 3600 seconds, 1 hour. Okay. So, if I can design it, if I am somewhere here and let us say that I am not going to lose cost material in terms of material and manufacturing and all that by going here, I will save so much in assembly time. So, I should actually move my design from here to here, so that I will save on my assembly time. That becomes important. And please always remember that we are talking about manual assembly here, not the robotic assembly, not yet. In robotic assembly, these graphs will change, but the idea is still the same. Okay. So, these are cylindrical parts and these are non-cylindrical parts that you are talking about. And the other one is, these are the curve for long cylinders if thickness is equal to the diameter. Okay. That is the one that we spoke about. It is slightly, it is going to, it is going to take some time, some penalty is there if it if the thickness is equal to the diameter case. Okay. You see this? If it is less than 2 mm, you usually require a tweezer or a forceps to handle it. That is where the penalty comes into picture, because now I have to handle that tool, there is some time for it, then I will have to handle this guy and then put it back. So, look at the intricacy, the level of intricacy that they have gone into. Okay. But because this was a detailed study, their entire career was based on this, and today they have this DFMA toolbox, which is a commercial version is available, that many of the design companies rent it or lease it or buy it to use it. The next one is part size. So, we have spoken about symmetry, we have spoken about thickness, and the next one necessarily is, because he also asked this question of hollowness. Just because your thickness is more, does it mean that I need 3 people to carry this? No, not necessarily. It was a very thin sheet of element. Okay. It was just a, what you call, like a sheet of aluminum sheet that I folded into like this. So, I might still be able to carry it as a single person, it is not a concrete stuff. So, I need to be able to bring out my weight, that is called size. So, please look at the terminology that they are using. Thickness is not size, size. So, you will look into this one. It is very similar though. What size says is largest non-diagonal dimension of the part's outline, not the inside surface, the outline, when projected on the flat surface. This is the second one that I told you for thickness. You remember I said that you take a light and project on it, right? That's usually used for size. So, you keep the component, and then you project light over it, and you just need to look for the largest non-diagonal dimension, not other than the diagonal, you need to look for the non-diagonal. So, what would be the size for this guy? It will be the length. So, you can see here, it is very similar, whatever I showed you, in spite of all these things, it does not matter. You see this cut out, right? It does not matter. When you project light, it will just say that this is the largest dimension. Similarly, in this one, okay. In this case, it is L is less than D. So, your size is D, because that is the largest dimension, and this is a kind of a jump club. What is the size? This is my size. So, the size kind of represents your weight, that is the catch. Okay. Now, part size versus time, similar to the previous one, you can see that now at around 10 mm, they are kind of around that 10 to maybe around 15. Around 15, they are saying that greater than 15 mm is large, less than 15 mm is medium, somewhere around I do not know 7.58 it becomes small, something less than 2 mm is very small. Okay. And there are non-cylindrical parts and cylindrical parts. So, you can see if you were to design at this region, you would rather choose a non-cylindrical part instead of a cylindrical part, because your assembly time or the time penalty that you pay for is less in a non-cylindrical part compared to a cylindrical part. Okay. Cylindrical parts has some limitations because they are cylindrical, you do not have grips to hold them, okay. Whereas, if it was a non-cylindrical part, you might have sharp edges, so that not sharp, you would have defined edges, so it is easier to hold it. So, you can see pens that has non-cylindrical non-circular cross sections, actually they have better grip. Even if you see, even the cylindrical pens, oftentimes they have very minute linings around them. Okay. The old pens they used to have, or even the new ones, the cello pens, you have a grip near where you hold it, because if it is a pure cylinder, then you will not get a grip on that. Okay. And any kind of a ballpoint pens that you see, you will have linings there, that is to provide grip for you. Okay. Instead, there are also people are now coming up with triangular cross sections, they actually have a better grip. Still for you to hold it in these 3 fingers, you need something that is very close to a cylinder, because from an holding perspective, cylinder is still a classical design. Okay. But then from a grip perspective, you need to introduce grips either on the cylinder, or you need to modify the cylinder a little bit, so that it will give you grip, at the same time it is easy to hold. So, there is a very nice design paradigm there. Okay. These are just some introduction, right. I have just uncovered a little bit of discussion. It is up to you to go back to the text and see. For this, the classical book that we discussed is the Boothroyd's PDMA, Product Design for Manufacturing and Assembly. That is a book. Okay. All these pictures are taken out of that book. So, if you want, that is a textbook that you need to refer to. And there are questions on insertion difficulties. What do you think could be a difficulty in insertion? No, see, all this correct, coefficient of friction is one thing. What I am trying to tell is, again you need to have this stuff. There is a time penalty on this side, and this is the difficulty stuff. Okay. So, what is the, in that sense, what could be the insertion difficulties that you can think of? It is basically the resistance that is offered. We discussed yesterday, right. If there is a air trapped in, you need the air to be let out. So, you need to have a passage for that, or you have holes in the screws that lets you do that. Okay. These are insertion difficulties, sometimes handling difficulties. Okay. You have a component like this. okay. Your size, let us say that it was, the thickness was like this, okay. Size, thickness, everything is beautiful, but you have difficulty in handling this guy. These are sharp edges, okay, for this guy. So, that also need to be quantified. Okay. Restricted vision, certain things cannot be removed or adjusted without specific projection of light on that. That is because it is a restricted vision. Now, you imagine going to a doctor, okay. You tell him or her that I have pain here. Have you ever seen that they take a torchlight and put it here and then see what happens? Because either they should be able to see it in naked eye or they need a X-ray. The torchlight is not going to work. If you go and tell them that I have pain here, I have pain there, immediately what they do? They take a torch first and then they see. So, that is restricted vision. You cannot just see like this, okay. They do like this and they cannot see like this. They really need a torchlight to look into it. So, that is a restricted vision, okay. Even in surgical setups, okay, sometimes what happens is even when you cut open, you really need to cut open some part to look at a particular organ, because that is restricted vision, okay. That is the idea. Restricted access is also a problem, okay. Restricted access, any organ inside is restricted access, you cannot just see it just like that, but there is a reason for it, and then you have other ways to look at it. So, that is one thing, and you cannot keep everything for easy access, they have to be kept inside, right. So, sometimes tools used, what is the different types of tools? I need to use a screwdriver, I need to use a wrench, okay. You need to have special tools, special type of screwdrivers you need, and I told you, right, like for the Mac desktop, you cannot just have a screwdriver or a special type of a screwdriver, you need a vacuum puller to remove it. I need a special tool. Then the cost is more, the penalty is more on that. That is the catch, okay. Types of fasteners, okay. So, for instance, you know, you can have a nail, you can have a screw. In screw itself, you have so many different types of screws, and there is a time penalty for each one of them, okay. And etc. It keeps going. So, basically it leads to a decomposed chart of likely time to be taken. For each of this, there is research done and they have a graph like this. So, for each one of this, you know what it is. In terms, I mean, anything you can imagine, probably it is like this for something else, and then they will say here is the value and I have some numbers here.